Let's see how to use the completing the square method to solve quadratic equations. Now, first of all, if a quadratic expression is written in this form, x squared plus ax, it is incomplete, and it can be completed, it can be made complete by writing it in the form x plus p all square minus q, where p is the square, where p is half the coefficient of x. The coefficient of x is a, that means p is half a, and q is the square of half the coefficient of x. That means q is the square of half a. Q is the square of half a. Now let's take a few examples. Write the quadratic expression x squared plus 2x in complete form. This will be the same as x plus, the coefficient of x is 2 and half of that is 1. So that's x plus 1 all square minus the square of half the coefficient of x. That means minus 1 square, because 1 is half the coefficient of x. And what does that become? And that becomes x plus 1 all square minus the square of 1 is 1. And that's the complete form of the quadratic expression x squared plus 2x. Now let's take another. Write x squared minus 5x in complete form. That's going to be x. Now the coefficient of x is minus 5, and half of that, which means 1 over 2 times minus 5, and which is equal to minus 5 over 2. Half the coefficient of x is minus 5 over 2. So I'm going to write x minus 5 over 2 all square minus the square of that half the coefficient of x, which is minus the square of minus 5 all over 2. And what does that become? Minus the square of half the coefficient of x. And that simply means x minus 5 over 2 all square minus the square of minus 5 is 25, and the square of 2 is 4. And that's the complete form of the quadratic expression x squared minus 5x. Now let's take another example. Write 3x squared minus 7x. Write 3x squared minus 7x in complete form. First of all, we can see that the coefficient of x squared here is not 1. So we can factor 3 out of the two terms, which will now mean 3 into brackets x squared minus 7 over 3x. You would see that if you expand the right hand side, you will get what is on the left hand side. If you expand 3 into brackets x squared minus 7 over 3x, you're going to get 3x squared minus 7x. Now what we do is complete the square for x squared minus 7 over 3x. And what we now have is 3 into brackets x. The coefficient of x is minus 7 over 3. And half of that means 1 over 2 times minus 1 over 3, which is minus 7 over 6. So here I'm going to have x minus 7 over 6 all square minus the square of that half the coefficient of x, and that's minus the square of minus 7 over 6. That's minus the square of minus 7 over 6. And the next step will be 3 into bracket x minus 7 over 6 all square minus the square of minus 7 is 49, and the square of 6 is 36. We close the bracket. And what do we have next? The next step will be, and that will be equal to, now we can open the bracket. That's 3 into bracket x minus 7 over 6 all square minus, and now I'm going to do 3 times 49 over 36. 3 times 49 over 36. 3 here 1, 3 here 12. And that simply means 49 over 12. And that is simply, and that's the complete form of the quadratic expression 3x squared minus 7x simply. Now let's take an example. We want to now see how to use this method of completing the square to solve a quadratic equation. Solve the quadratic equation. Let's solve this very simple quadratic equation. X squared minus 5x plus 6 equals 0 by the method of completing the square. First of all, let's move this 6 to the right hand side. And we have x squared minus 5x equals minus 6. Now, we can complete the square for x minus 5x. And that simply means x, the coefficient of x is minus 5, and half of that will be minus 5 over 2. That's x minus 5 over 2 all square minus the square of half the coefficient of x. Half the coefficient of x is minus 5 over 2. So that's minus 5 over 2 all square minus the square of minus 5 over 2 all square. And that's equal to minus 6. And so where do we go? What's the next thing to do? That simply means x minus 5 over 2 all square minus the square of minus 5 is 25 and the square of 2 is 4 equals minus 6. Now I want to move minus 25 over 4 to the right hand side, and when I do that it will become plus 25 all over 4. That means on the left hand side I'm going to have x minus 5 over 2 all square, and on the right hand side I'll now have minus 6. When minus 25 over 4 goes to that right hand side, it becomes plus 25 over 4. Now what do? This simply means minus 6 over 1. Find the LCM, which is 4. I shouldn't be doing this, but just for you to understand. 1 in 4, 4 times minus 6 is minus 24, plus 4 in 4 is 1 times 25, that's 25. And that simply means x, the square of x minus 5 over 2 is equal to minus 24 plus 25 over 4. And that simply means x minus 5 over 2 all square is equal to minus 24 plus 25 is 1 all over 4. So, and that means now what we do is find the square roots of both sides. The square root of the left hand side is going to be x minus 5 all over 2, and the square root of the right hand side, which is this, is going to be plus or minus 1 over 2. You know that squares have 2 roots. So what we now do is this simply means x minus 5 over 2 equals plus or minus 1 over 2. Now I want to move minus 5 over 2 to the right hand side. And when it gets there, it becomes plus 5 over 2. Now, so that simply means x is equal to, when minus 5 over 2 goes to the right hand side, it becomes plus 5 over 2 plus or minus 1 over 2, which therefore means x equals 5 over 2 plus 1 over 2, or x equals 5 over 2 minus 1 over 2, which means x equals 5 over 2 plus 1 over 2. That simply means x equals 5 over 2 plus 1 over 2 is 6 over 2, and that's 3. Or x equals 5 over 2 minus 1 over 2 is 4 over 2, which is 2. And that's it, very, very simply.